Hey everyone, in this lesson I'm gonna talk to you about global and local data. In the previous lesson we covered global and local scope, and that ties directly into what we're talking about today. So let's jump in. Local data refers to any data that lives inside a block. For example, that could be a function, parameters, variables created inside a function, or variables declared inside things like if, switch, while, do while, for, or inside a statement scope. All of these are called local because you can't access them outside of the scope they're in, and their lifetime is limited to the block where they were created. Every parameter a function has is created when the function is called and destroyed once the function finishes. Everything that was declared inside the function also gets destroyed as soon as the program hits the closing curly brace of that block. That's why we call them local. As I said and showed in the last lesson, you can create data outside of functions. That includes anything: variables, constants, arrays, pointers, and references. You can define them anywhere outside of functions, but it's common practice to declare them at the very top of your file above all functions, so you don't have to hunt around to find them. These are called global variables because they can be accessed from any function in the same file, and even from other files if you set it up right. Now, in the file where the global variable is declared, its scope starts from the point where it's defined and goes to the end of the file. That's why you might get an error here. The compiler reads top to bottom and it hasn't seen the variable yet. So that's one more reason why global variables should go at the top of your file before any functions. There are two key differences between global and local data. First, global variables are stored in a special kind of memory called static memory. We'll go over memory types in detail in another lesson. For now, just remember this means they're created when the program starts and live until the program ends. Local data, on the other hand, gets created and destroyed as the program runs. Second, global variables get automatically initialized to a default value if you don't do it yourself. I will left a comment showing what those defaults are. Because of this, you'll see something interesting in this example. We create a constant but don't assign a value to it. If that happened inside a function, it'd throw a compile error. But here it works, because the constant gets initialized to 0. Still, don't do this. It's bad style and confusing. Now, you might be asking, why do global variables get default values but local ones don't? It's because global data is stored in memory controlled by the operating system, which guarantees that everything is initialized before your program runs. Local variables go on the stack, we'll talk about it soon, which doesn't get wiped automatically. So local variables contain garbage by default. This gives C++ a big speed boost, but it also means you've gotta be extra careful. By the way, now that you understand all this, you can actually set things up so you don't have to call setRandomSeed inside main. You just create a global variable called isRandomSeedSet with the type bool. You can update setRandomSeed so that it returns true at the end, and then assign that to your global variable. Now you don't need to call setRandomSeed in main at all. Just use randomIt and randomDouble right away. Why does this work? Because global variables are initialized before main is called, so the call to setRandomSeed happens before main starts. You can now save this random number generation setup somewhere and reuse it whenever you want. That's exactly what I'll be doing. I wrap the code block using the pragma region command, which lets you fold code for better organization. I'll cover that command in more detail in another lesson. For now, just copy and paste the code to wherever you need it. And in future lessons, you'll be seeing this same code block show up often. Back to global variables. Let me open up project 3. It has some code you already understand. We've got an uninitialized array that we fill with random numbers and print out. The array and the constant are local, so we have to pass them around to different functions. But we could make them global instead. Let me jump to project 4. What's the benefit of doing that? Well, now we don't need to pass the array and its size into functions because they already see the global data. So the code's a bit shorter, but at what cost? Now, if someone's reading main, it's not immediately obvious what's being initialized or printed. You or any other developer will have to dig into the functions to figure that out, and that's a real downside when working on a big project. Why should programmers avoid creating global data? First off, global variables can be accessed from anywhere. That might sound convenient, but the problem is anyone, anywhere in the code can change them. If your program is large and packed with functions that all touch the same global variable, good luck figuring out who changed it, when or why it suddenly got reset to 0. Second, it makes your program harder to debug and understand. A global variable can suddenly change in a totally different part of the program and you won't even notice right away. It's like everyone sharing one backpack and then one day the food's gone. Who took it? When? Where? No idea. Now you have to waste time tracking it down. Third, globals break encapsulation. Encapsulation means keeping data hidden inside something like an object and controlling who can access or change it. Global variables are like an open drawer that anyone can mess with. There's no control, no protection. Fourth, they make it hard to reuse code. Good code is portable. You should be able to move it to another project. But if your function depends on a global variable, you can't just copy and paste it. It needs the global context to work. Fifth, globals are a headache in multi-threaded programs. If multiple threads access the same global variable, you can run into race conditions. One thread writes while another reads, and everything breaks. We'll talk about multi-threading much later in the course. And sixth, they can lead to hidden dependencies. Your code looks simple, but under the hood, it relies on global state. That means the same function might behave differently depending on some outside factor, which makes your code unpredictable and harder to test. But sometimes using global variables is actually okay. For example, when you're creating global constants, these always have the same value and can't be changed, so they're safe. Another good use is for data that represents global program settings, stuff that really does need to be accessed from multiple modules, or things like logging. If it's well organized, having a global log system can make sense. Here's a simple takeaway. Global variables are like food that everyone can grab with their hands. It's convenient, sure, but it can lead to mess and even illness. It's way better to keep your food in your own container. It's cleaner and safer that way. After hearing all my warnings, you might be thinking, okay, then why are cout and scene global variables? If globals are so bad, are the people who designed C++ worse programmers than you? Of course not. The thing is, these are special cases. Cout and scene need to be available everywhere. They're used in main, in other functions, even deep inside library functions. So why don't they cause the same problems? Because they are carefully designed and well thought out. They're safe to use. The standard library handles internal synchronization to make sure there are no conflicts between threads. Unlike user-defined global variables, the behavior of cout and scene is predictable. They serve as the global input-output interface for the entire program. One screen, one keyboard, so it makes total sense for them to be global. And they're convenient too. Imagine having to pass cout into every function. Yeah, no thanks. And that's the end of this lesson. Thanks so much for watching. I hope you found it helpful and maybe even enjoyed it. If you did, you can show your support by giving this video a like, leaving a comment down below, subscribing to the channel if you haven't already, or even donating via the link in the description. You can also become a channel member to unlock access to all the practical lessons, where you'll be able to practice and solidify everything you've learned. All of that really helps grow the channel and keeps me motivated to keep making more lessons like this. Wishing you smooth and enjoyable learning. Take care and see you next time.